So we're heading into chapter 14 today. And chapter 14 is going to deal with like data and kind of visualizing what that data looks like. And we're going to start off with something called line plots. And these are things that you've seen before. Line plots look like this. They have a bunch of numbers on the bottom, and then a bunch of different X's on top of that. Now, each of these X's actually symbolize somebody like voting or somebody being something, or something being something. So what we have is our data on our left. And it says, the table below gives the number of miles Frida ran over a period of days. A line plot shows the data along a number line. Each X represents the number in a data set. And that's what I'm saying. Each one of these X's represents a number. It represents a day. So on 2 of the days, she ran 2 miles. Okay. On 3 of the days, on 4 of the days, she ran 3 miles. On 5 of the days, she ran 4 miles. On 3 of the days, she ran 5 miles. On 2 of the days, she ran 6. And one day, she even ran 12 miles. And that's what we see over here. We see, okay, 2 miles. I believe that's miles down here. Yep. For a day, how many days did she run 2 miles? Well, 2. How many days did she run 3 miles? 4. 4 miles was the most common, and that means she ran 4 miles on 5 of those days. So each of those X's represent a day. Now the question is this. On the line plot, each X represents one day. An outlier is a number in the data set that is really different from everything else. An outlier is something that is like way out there, either a lot less or a lot more than every other number set in that data. So looking at our data, you kind of see this little curve right there. And then you kind of see this guy way over here. And because this X, because this 12 miles is way outside the normal range of data, we would consider that an outlier. So when it says, is there an outlier in the data above? Explain, yeah. I would say 12 is our outlier because it's more than double every other data point within our line plots, or exactly double. So that's where we know that 12 is our outlier. It's not that it's that much more, it's just one of them too. It's just like one X way out beyond everything else. So I'd say 12 is definitely our outlier because it's well beyond the normal range that Frida runs every other day. And that's what we're gonna be looking at today. We're gonna be looking at line plots and then kind of looking for outliers in our data as well. On the bottom it says, complete the line plot to show the data in the table for puppy's weight at the birth. Identify the outlier in the data set. So this is our weight. And this is the number of puppies. So when we look at our line plot, we know that this number, these numbers on the bottom represent the weight. And looking at this, it looks like we have 5 that weigh 3 pounds. Okay, cool. 1, 2, 3, 4, 5. You want to kind of make those X's kind of consistently the same size. Otherwise, your data is going to look kind of skewed. So we have our 5 X's on top of our 3. Each one of those X's represent a puppy. Now, we have 3 puppies that weighed 4 pounds. 1, 2, 3. Again, noticing that I'm using the same size X's so you can kind of see, okay, 3 is a little bit bigger than 4. For 5 pounds, we have 2. 1, 2. For 6 pounds, we have 0, so we wouldn't put any, right? Yep. And for 7, we have 1. And then way, way, way all the way to the side, we have 1 really fat puppy. And that'd be at 13. Now notice, if I would put like an X like that, that would kind of make my data look very different. That would look like, oh, there's as many 13s as there are 3s, just because you can look at the height. And that's why we want to make sure that our X's are relatively the same size. We don't need to get a ruler out or anything like that. And that's what our line plot looks like. You see the majority of, or the most common weight for puppies is 3. The least common would be, well, anything that has 0. And then we have an outlier as well, 13 that's way off to the side. So it says complete the line plot, identify the outlier in the data set. And I would say my outlier is 13. And that's what you're doing today. So I'd like you to head to the next page. That'd be the practice 14-1. And you're gonna just do the page if you possibly can, and then check with the answers as well. If you have questions, again, let me know. We're gonna be working with data and kind of graphing data this entire chapter. It's kind of a fun little, a fun way to kind of visualize math. It's not as like intense with multiplication or division or fractions or decimals or anything like that. Just kind of looking at math as like this picture almost instead of just numbers. So cool, thanks.